welcome back to my channel. Today we're going to explore what rational numbers are. We're going to look at how to convert fraction to decimals and also the NAPLAN questions, specifically on how to convert fractions to decimals. Let's start with rational numbers. So in English, rational means being reasonable, logical, or based on clear thinking. So when we say a rational number in maths, we mean a number that is and can be expressed in a clear and reasonable way. It can be a fraction of two whole numbers. There are a couple of examples on rational numbers. It can be firstly whole numbers like 5. How can we express 5 as a fraction? Well, it can be written as 5 divided by 1. There's always the 1, a little denominator under 5, and we get little 5. So any whole numbers, doesn't matter 2 or 3 or 1. When we want to express it as a fraction, we just divide it. We can just write it like this. Use a little bar. We can put a 1 underneath as a denominator. And rational numbers can also be an integers, -2, -1, 6, 7, it goes on. And similarly, for those integers, when we want to express as a fraction, -3, we can always put a little 1 underneath. It can be written as -3 divided by 1, like this. When I express the integers and whole numbers in fractions, they can be written as like this. Let's have a look. Well, it's exactly the same. 3/4 -2 by 5. They are all fractions. Okay, what about terminating decimals? This is what we call by terminating decimals, 0.25. There's nothing, no digits continuing after 5. So when we divide our 25 by 100, we get 0.25. No more than that. We have repeating decimals. So what that looks like is 1/3 equals to 0.333333333. It goes on. It's never ending. And that is why we call it a repeating decimal, because 3 is repeating itself. In maths, we use a little way to write repeating decimals. So we don't want to keep repeating our number 3s. We will just use little dot on top of 3 just to show, okay, in this decimal, 3 will be repeating. We can also use the little bar on top like this, 0.3, a little bar. So today we will explore how to convert fraction to decimals. So there are two types of fractions. The first one is proper fraction and the second one is improper fraction. What is a proper fraction? A proper fraction is where let's say there is a divided by b, a being our numerator and our b being a denominator. So when we think about a proper fraction, our a will be less than our b. So it can be, for example, 2 divided by 5. We can see our numerator is less than denominator 5. It can be like 7 by 9, anything really. I'm just going to keep going with 4 by 5, and we get 5 by 5, which is equal to 1. And we get 6 by 5. Look, our A, the numerator, is going to be bigger than the denominator. That's when we call it is an improper fraction. Doesn't belong to our proper fraction anymore. It belongs to our improper fraction, where our numerator a is bigger than our denominator b. So we can also write 6 divided by 5, or 6 by 5, or 6 over 5. There are a few different ways to call a fraction as a mixed fraction. So what mixed fraction looks like is there's a number in front, little bar, and then as usual, there will be a numerator and denominator. Let's just keep number in front here, C. It's going to be written as a mixed fraction. So let's try and convert our 6 by 5 into a mixed fraction. Well, we're going to have to divide our 6 by 5 like this. How many times 5 into 6? 5. Yeah? We get a quotient 1. I'm going to write a Q on top. And the remainder 1 is 5. In mixed fraction, we start with our divisor 5 here. And then we can think about how many of our 5 has been remained when divided into 6. Well, there's a remainder 1. So we just put it on top there and just copy the quotient, which is 1. So 1/5 is equal to 6 divided by 5. All the materials being adapted from Essential Maths for Australia Curriculum 3rd edition, Cambridge University Press. We're going to be exploring in NAPLAN questions as well, specifically chosen on the topic of converting fractions to decimals. Before that, let's look at some examples on how to convert fractions to decimals. It says, write these fractions as decimals. Well, we have 2/5. So, as you can see, we got a mixed fraction here. How do I know? There's a little number in front, followed by the fraction. So that's a mixed fraction. There are two ways to solve this problem. First, you can just leave the little 2 there, deal with 2 divided by 5. The second way is you can convert our mixed fraction to improper fraction and then deal with the rest. So let's start off with our first method. Okay, I'm just going to leave number 2 there. Let's deal with 2 divided by 5. Well, I'm going to use an old-fashioned long division way, just like this. I'm going to write 2 and then 5 over here. Divisor is bigger than our dividend, so can't divide into 2, right? So we're just gonna write 0 on top. 0, we're gonna subtract and write 2 over here. Then the reason why I did like this is because I need 2 digits to divide by 5. I'm gonna write 0 here. There's an imaginary zeros every whole numbers, a little decimal point. Quotient will be in decimals. Let's copy that down, 0, and how many times of 5 will give that 20? Well, 5 times 4 will give us 20. There it is. We have our remainder 0, and we got our 0.4. Now, it's not done. Next step is, don't forget this little 2 here. We just left it there. We need to plus it with our result 0.4. And it will give us 2.4. The second way of doing this question is we're going to convert it to the improper fraction. I'll just copy the question for a bit here to 2/5. When we convert it to our improper fraction, all you got to do is multiply our denominator with the number in front. It's 5 times 2, and you add with the numerator. Add the number 2 like this. So I'm gonna work out step by step so you can see. 5 times 2 gives me 10 plus 2. It gives me 12. We still need to put our denominator. Never ever forget our denominator. So 12 divided by 5 will be our improper fraction. We need to convert it to decimals. go a simple and easy way, an old-fashioned way, just like this. 12, 5 gonna divide into 12. Well, there are two digits to work with. How many times 5 will give us 12? Or any closest to 12? 5 times 2 will be 10. And so when there's a two digit, we put the number there right on top of the last digit. We divide it into. So what's the remainder again? Give us 2. We still got a remainder. Now we need to keep going so that is 0. We use our imagination again. There's imaginary zeros in our whole numbers after decimal point. So we will add zeros. I'm going to use a different color so you can see. 0, I'm going to drag that 0 down so I have two digits to divide my 5 into. So how many times 5 will give 20? 5 times 4 will give us 20, and the remainder is 0. There it is. 13. Oh, I have got a proper fraction. How do I know it's a proper fraction? Well, our numerator e is smaller than our denominator b. We're going to divide our 13 into 5. So first, we need to work out the multiplications of 13. If you know it by heart, it's okay. It will be great. If you don't know by heart, we're going to have to work out on here. This page, 13 multiplied 1, 13, just have it written here, 13 multiplied 2, give us 26. 13 multiplied 3 will give us 39. I'm working out mentally. 13 multiplies 4 will give us 52. You can also use like methods like this. 13's multiply 5, like this. So what 5 times 3 will give us 15. Put the 1 on top here. 5 times 1 will give us 5 plus the 1 will give me 65. What about 13 multiply 6? 6 times 3 will give me 18. Put the 1 on top of another digit. 6 times 1 will give me 6, plus the 1 will give me 78. We can keep going, or we can stop right there for a bit. Look at that. I need two digits to work with. So I'm going to use my imagination again. Put the little dot here and 0 here. Oh, before that, well, how many times 13 will give us 5? Well, no times. There's nothing. So I'm just going to have to drag it down. Just have to subtract our 0 from 5 and it gives 5. Now there's a little decimal point followed by zeros. We drag the 0 down like this, just like usual. So how many times 13 will give us a number closest to 50? Now we can check on our left-hand side. 13 times 4 is 52, which is more than our 50. So we just have to ignore that for a bit. 13 times 3 is the closest to 50. So 3, I'm going to write that on top of our 0. And 39 will give me, you can borrow the 1 here. It will be 4. And there will be 10. Subtract 9 will give me 1. 4 minus 3 will give me 1. Okay, well, we have two digits to work with, and we also have two digits to divide it into. But then our two-digit remainder is smaller than our divisor 13. So we need to 0 and drag the 0 down again. So now we have three digits to divide it into. Okay, so what number multiplies by 13 will give closest number to 110? Well, we need to keep working out with our multiplications, don't we? I'm gonna work out 13 multiplies by 7 will gives me 7 times 3 will be 21. 7 times 1 will gives me 7 plus a 2, 9. It's close to 110. But let's keep going. One more. 13 times 8 will gives me 24. 8 times 1, 8. Plus the 2 will be 104. Ooh, it's 104. I think this is the closest one. If I subtract 104 from 110, it will give me only 6. So I think we just need to stop right there. 13 times 8 will give us 104. So it will give us 6. Just did it mentally, but you can still borrow the 1 from 1. It will give, yeah, 6. There it is. And we keep going. Oh, there's only 1 digit to work with in the remainder, so let's track down our 0 again. There is 0. So I'm glad we have worked out all the multiplication on my left-hand side. Look at it. We have 2 digits, 60. What number will be closest to 60? So 13 times 4 will be 52. It's the closest, not over 60, yeah? So we subtract 52 from 60, and we will get 8. Let's keep going. We drag the 0 down. 13 multiply 6 will give us 78. And subtract, we will get 2. And we still need to keep going. 13 times 1 will be 13, 7. Keep going, drag the 0 down. We're going to divide 13 into 70. How many times 13 will give us a number closest to 70? 13 times 5 will give us 65. We get 5 remainder. And we need 2 digits to work with. So keep going, dragging the 0 down. Oh, I can now see my 50 and I can feel a repeating pattern. 50 is right here too. Should we stop there? Should we keep going? I will keep going to see what's going to happen next. 15 times 3 will give us 39. Oh, look at that. It gives us the 11. We got 11 at some point. Where did we get 11? Happening here. And here again. So it's repeating itself. And there's 3, 3. So I know where to stop. I'm just going to cut off right there. So how can we write a repeating this decimals? Well, 5 divided by 13 is equal to 0.38461.5. Now we put a little bar on top to show a repeating pattern. Let's have a look at how to convert fraction to decimals in NAPLAN questions. So this is one of the past paper question that happened in 2014, question 29 on page 11. It asks you the fraction 1/8 equals 0.125 as a decimal. What does 1/16 equal as a decimal? So there are 2 ways to solve this questions. One, you can just 0.125 divided by 2. You can work with 1/16 here and use a normal old-fashioned devising tool like this. What we're going to divide 16 into 1 like that. So let's just start off with the first method where you're going to divide 0.125 as a decimal. Let's back up for a bit. Why do we have to divide 0.125 as a decimal? Well, when you think about it, let's draw a diagram so you can understand why it's being halved. So 1/8, it looks like this. You can draw a little pie. So imagine there's a 1/8 of pizza on the table. So 1, 2, 3, 4, 5, 6, 7, 8, like that. So 1/8 equals to 0.125. Now another 8 more people join in. They also want the pizza, but we only have the 8 pizza. So what we're gonna do is we can divide up our 1/8 8 pizzas, yeah, and we can divide it up like this, each one. It will give us 16 pieces. This is our 8 pieces, and this is our 16 pieces. Now everyone will have each piece to enjoy. So when you think about it, 1/8 is 0.125, and now all we did was we halved that one bit into 2 like this. Then that is why we can halve that 0.125 divided by 2. So that is our first method. This is a non-calculator question, so you gotta work on your division skills with decimals. So 0.125 divided by 2. You just keep going like this. Ignore the decimal for a bit, and you can drag the 0 down, gives us 0 and 1. Well, there is 1 over here. The remainder is 1, but our divisor is 2. So we still need to drag down another number to work with. Before that, we can just put it there, 0 on top, and we can work with 0. And let's drag it down. There's 2 now. What multiplies by 2 will give us 12. 6 multiplies by 2 will give us 12. Well, now it's become 0. Gives us 5. There's this remainder of 5. Well, what multiplies by 2 will give us the closest number to 5. 2 multiplies 2 will give us 4. It will be, there's a remainder 1. And there's only one digit to work with. So what we need to do is we need to add 1 0 there, that 0 down. What multiplies by 2 will give us 10. 2 multiplies 5 will give us 10. So the remainder is 0. Now we have left with 0, 0, 6, 2, 5. Where do we put our decimal point? Well, we can see there are 4 digits the back. So all we gotta do is we need to leave our 4 digits, and then we just add our decimal point right over there. It will give us 0.0625. We can check with our second method. Let's have a look. The second method is we need to know the multiplications of 16, just like the previous example. 16 multiplies 1, 16, 16 multiplies 2 gives us 32. The 3, it's 9. I just did a couple so that I don't have to go back and do the multiplications. Now back to our real division work. So if we divide 16 into 1, well, we can't do that. It's not divisible. So we have to put a 0 on top, and we put the 0 at the bottom, and we still have to work with our 1. So they're always the imaginary zeros. Drag it down. Still divide our 10, the remainder 10, into 16. No, actually not. So we need to keep going with the top one. So now it's become a decimal. And 0.0. We drag that 0 down, minus, we have left with our 0 there. Oh well. Now we can add our zeros. Drag that down, 0. We have 3 digits to work with. So how many times 16 will give us a number closest to 100? We can see 16 times 6 is 96. There it is. We just subtract 96 from 100. It gives you 4. So drag the 0 down. So how many times 16 will give us a number closest to 40? 16 times 2 will give us 32. We subtract 32 from 40, and we have left with 8. And we add our one more 0 to see. Let's work that out. How many times 16 will give us a number closest to 80? Well, we got 16 times 5. Oop, exactly the same. Is 16 times 5 will give us 80. So the remainder is 0. The answer is 0.0625, which is the exact same answer as our previous method. So I want you to have a go, a few examples. 2012, non-calculator and calculator. The solutions will also be available in the comment. All the materials are from NAPLAN 2012 to 2016 and also 2008 to 11, the Australia Curriculum Assessment and Reporting Authority website. So I have also, I forgot, I have also provided you with a question template. Please go over these questions after you've watched the video.